The process of dividing rational expressions is the same as the process for dividing rational numbers, or fractions. So let's remember our rules for dividing fractions. When you divide fractions, you want to change the division problem to a multiplication problem by writing the inverse, the reciprocal, of the second fraction, of the divisor. And then you multiply across, just like you would with any other multiplication problem. So let's look at the steps for rational expressions. First, like I said, you need to rewrite the division problem as multiplication. Sometimes this is called keep, change, flip. Then we do our same steps for multiplication. We factor our polynomials, we remove our common factors, and then we multiply across. So let's do a few examples. In our first example, we notice it's a division problem, so our first thing we need to do is to rewrite it as a multiplication problem. Don't try to cancel common factors first, because you can't do that until it's a multiplication problem. So we keep our first fraction the same, change our division to multiplication, and then write the reciprocal of the second fraction. Now there's no common factors to remove, so we just multiply across. 8 over n squared. Now let's do our second example. Again, let's rewrite our division problem as a multiplication problem. X minus y divided by 6 times 3 over y minus x. Now let's look to see if there's anything that we can factor. And we have two binomials, but we'll notice that these binomials aren't the same right now. One's x minus y and one's y minus x. But if we were to factor out a negative 1 out of one of these binomials, then they would become the same. So x minus y and y minus x are opposites of one another. And so when you have opposites, you want to factor out a negative 1. So let's look at what that would mean. That would mean that if I factored a negative 1 out of y minus x, my positive y would become negative y, and my negative x would become positive x. I notice I rewrote the order, putting the x first, so that my first term was positive. And now, let's see what we can remove from these two fractions. We can remove our factor of 3 by dividing these two factors by 3, so we're left with 1 and 2. And now we can remove our x minus y and this x minus y. And so now when we multiply across, we're left with this. In the numerator, 1 times 1 is 1. And then in the denominator, 2 times negative 1 is negative 2. If you think you've got the hang of it, try these two examples on your own by pausing the video and then resume the video when you have your answers. Okay, let's give these a try. Let's rewrite our division problem as multiplication problem, and to save some time, I'm going to factor at the same time. So x squared minus 1 is x plus 1, x minus 1, and my denominator stays as x. Then I factor out I change my division to multiplication, and then I rewrite my second fraction as x plus 1 goes in the denominator, and the numerator I factor out my GCF of 5, which leaves me at, 5x. And when I do that, that leaves me with x minus 1. Now I want to cancel any of my common factors. So I have x plus 1 in the numerator and x plus 1 in the denominator. Those can be canceled. And x minus 1 and x minus 1, since these are both in the numerator, we can't remove those common factors. So let's see what there's one more common factor we can remove. This x can be removed with my other x, because those are both common factors as well. So now I'm left with, when I multiply across, in the numerator, 5 times x minus 1 times x minus 1, or 5 times x minus 1 squared. And in the denominator, when I cancel these, I'm just left with 1. So instead of writing this over 1, let's simplify it a bit more. Call it 5 times x minus 1 squared. And that is my simplified expression. And let's do our last example here. Let's remember that 2x squared plus x minus 3 is the same thing as having it over 1, and that's important when we flip or write the reciprocal of that second fraction now. So let's rewrite this. Division is multiplication. X plus 3 over x plus 1 times our 1 goes in the numerator, and now let's try and factor this trinomial. It's going to be 2x and x. And so we'll probably use 3 and 1 for our second terms of the binomial. And so we'll put our 3 here and our 1 here. And it need to be a positive 3 and a negative 1. This is the trial and error process. You might want to check your work to make sure you've done this right, but I believe that this is now factored correctly. And let's see if there are any common factors that can be removed. It doesn't appear that there are, and so we'll just write our final answer by multiplying across. We'll get x plus 3 in the numerator, and in the denominator we have x plus 1 times 2x plus 3 times x minus 1. And that is our answer.